Good morning, students. Example 2, this was our first question assigned over the weekend for homework or on Monday for homework. We actually did this on our notes already. I didn't realize I repeated the same question, y'all. So if I could just quickly give you a reminder, all of these equations are in standard form. Remember, standard form is when you have your x term plus or minus your y term equals a number, your c term. So these are all in standard form. And this is when you can utilize the cover up one variable, calling it 0, and finding the intercepts of the graph. So we know that's 0, 4. This is 9, 0. So we need the equation of the line to have a y-intercept of 4 and an x-intercept of 9. So just real quick, just to remind you, in order to find the y-intercept, I cover up the x-coordinate so that all I see is a y. That's how I'm going to find the y. And now I know that y is 4. So 0, 4 would be the point on the graph. And then I would cover up the y coordinate, making that 0, making the y 0. That's why I'm covering it up. And I would divide by 4. And I would get x equals 9. And now I know that this one line had both intercepts, just like the graph did. I could also prove that the top line, if I cover up the x and make x 0, then I divide by -1, and I get y equals -2. And if I zoom out super quick, guys, you'll see that the other line did have a y-intercept of -2. Of course, you can find this x-intercept. I know it's not a friendly number. It's between 0 and 1. And I can just prove once again that, don't know what happened there, that it is f by covering up the y. When I cover up the y, I'm putting a 0 in for the y. I'm dividing both sides by 3, and x equals 2/3, which is 0.66666, which makes sense. That number is between 0 and 1. So f is going to be the system that represents this graph. All right. The next question you had to do was number 4, example 4, on the next page. So really quick, it says which graph can be used to find the solution to the systems of the equations below. So remember, the solution is where the two graphs intersect. It's the point of intersection. So if we want to solve the top equation, all right, computer, you're going crazy on me. If we want to solve the top equation, remember, we're going to box the y, move the x. That gives me y equals -4 minus 2x. We don't need to divide because y has a coefficient of 1. So we're done. I know that this is my y-intercept. On our second equation, they've already moved the x. I just have to divide by the number next to y. Divide, divide, divide. That gives me the slope is down 2/3, and the y-intercept is also -4. I know that both graphs need to cross at -4. This has both lines crossing at -4. This one does not. This one only has 1, but that one did not cross at -4. This one only has 1, but that one doesn't cross at -4. So I know the answer is F. So on this question, you needed to rearrange both equations to slope-intercept form. Y equals mx plus b. I found that they both ironically had a y-intercept of -4, and this is the only graph with an intersection point at -4. So which graph can be used? Graph F, and they intersect at 0, -4, which happens to be the y-intercept. This is a unusual example where a system intersects at the y-intercept. Moving on to example 5, you needed to type both of these or all 4 of these into Desmos. So if I zoom out, I could just quickly type in y equals 1/2 x plus 3, get my line. Y equals, oopsies, y equals 4x minus 4, tap the screen. So I know the solution is 2, 4. There is one solution. For our second system, I have y equals -1/3 x plus 5. I have y equals -1/3 x. Notice they have the same slope. -1/3 is our slope, but this one's +1. Well, they have the same slope. They're equidistant apart. That would be no solution. The lines will never touch. Why? Because they're parallel. Same slope, different y-intercept, parallel lines never intersect. And the definition of a solution is where they intersect. On the third example, this one's ready to be graphed. So we've got y equals -4x, which is going down. Our example C, we need to box the y, move the 7 by adding. 7 and -7 makes 0. And this 7 and -7 makes 0. So my answer for this line is y equals -4x. So y equals -4x. Notice that my green line is overlapping my blue line. They are the same slope, -4, and they have the same y-intercept, 0, 0. So these two lines intersect all the time. So its solutions would be infinitely many solutions because the two graphs intersect everywhere. They intersect here, they intersect here, they intersect here, they intersect the entire line. That's why we say infinitely many solutions. In our last example, we would just type in y equals 6, which is a horizontal line. The slope is 0. So 0 slope. We'll also type in x equals -2, which is a vertical line. And x equals -2 has an undefined slope. Just know the difference. If it's an x equals, it's undefined. Remember slope dude, our little guy? When we have our slope dude, we have the positive eyeball, the negative eyeball, the undefined, because we put a little U under his vertical nose, and his mouth is a 0, and that's the number 0, and it's a horizontal line. So flat lines have a 0 like his dimple, and an undefined slope is like his nose because it's U for undefined. Okay, so the intersection point is, the same numbers in the equation. The x coordinate was -2, the y coordinate is 6. All right, keep it moving. Question number 1. The line graphed on the grid represents the first two equations in a linear system. If the graph of the second equation in the system passes through the points -12, 20, so where is -12, 20? Over -12, up 20 would be right here. And 4 positive 12 would be over 4 up 12 right here. That would be down 2 boxes over 4. Down 2 boxes over 4. Ooh, these lines are the same angle. When they're the same angle or slant, that means they have the same slope. They have different y-intercepts. These two lines are parallel. When you have parallel lines, the system has no solution. That's question 1. Question 2, another question about a no solution. This is from a STAR test. Which graph best represents a no solution? Well, this has a solution, can't be A. These on B will have a solution, so it can't be B. C has a solution, can't be C. D does not have any solutions, so it's D. Question 3, they're giving you the 2 questions in standard form. So you could use the cover-up method, or you can box the Y, move the X, divide, divide, divide. I'll do both. I will do the cover-up method for line 1. So I'm going to cover up the X. I'm going to put a 0 for X. We're going to find the Y coordinate. -4 is my coefficient. So Y equals -4. So I'm looking for a line that has a y-intercept of -4. And then I'm going to cover up the Y. When I cover up the Y, I got to put a 0 for the Y. I'm covering it up. I'm making it 0. I will divide by 8. My x-intercept is -2. So I'm looking for a line with a y-intercept of -4 and an x-intercept of -2. So can't be A. Oh, yeah, can't be A because I need a negative and a negative. I have a -2 and a can be B. I have a -2. Did I make a math mistake? Dang it, I did make a math mistake. I made a math mistake initially. Nabbit. That's a +4 because it's 2 negatives. Okie dokie. Now let's go back through. I need a +4 y-intercept and a -2. Okay, so nothing's on +4. I know it's not A. I have a +4 here and a -2 here. It could be B. I have a +4. No, I don't. Can't be C. I need a +4 and a -2. Nope, can't be D. So look, I found the answer with just doing the first equation. All right. So I could circle B and keep it moving, but I'm going to remind everyone how to do the second. Box the Y, move the X. You get 15y equals -6 minus 3x. Then you're going to divide everything by 15, divide, divide, divide. You would type -6 divided by 15 into the Desmos. It would tell you the answer is -2 over 5. And then -3 over 15 would be -1 over 5. So I'm looking for a line that crosses at a negative number right below 0, because that's in between 0 and -1. And then I need to go down 1 and over 5 and check it out. Right there, a little bit less than 0. And it's going to go down 1 and over 5 right there. Down 1 and over 5 right there. So that's how you could utilize using the cover-up method, which is replacing 0 for the X, finding the Y, replacing 0 for the Y, finding the X. Okay, page 5 was our warm-up. Okay, and then our last set of questions was page 8 and 9. All 6 were star questions. So question number 1 was star question number 54. What is the value of x, to the solution? So we need to find the solution point, and then we're just going to pull out that x coordinate. Remember, x is the first number in the point. I bet you they're going to have x and y as a choice to try to distract people. This one is ready to be graphed. So y equals 1/2 x plus 4, done. This one is not ready to be graphed. Box the y, move the x, divide, divide, divide. Nicely, this doesn't have a divide, divide, divide step because there's not a number in the box with y. This one was pretty quick and simple. If you just know to move the x by doing the opposite operation, you're good. All right, let's type this in. Y equals -1 minus 2x. Tap the screen. The solution is -2, 3. We only want the x coordinate. Ha, they do have both. I knew it. The answer would be G. Question number 25, which is question number 2. A college student completed some courses worth 3 credits and some courses worth 4 credits. So in college, when you take one class, you get 3 credits for taking that one class. And in this example, you take one class, you could get 4 credits, or you could take one class and get 3. The student earned a total of 59 credits after completing 18 courses. How many courses with 3 credits did the student complete? Okay, here we go. We're going to let courses worth 3 credits equal x. Courses worth 4 credits equals y. So we're defining our variables. Usually that's the first thing I have on every word problem is define your variables. X represents courses worth 3 credits. Y represents courses worth 4 credits. So they told us 2 different numbers for the total. A total of 59 credits, a total of 18 courses. There's our 2 equations. Equation 1, I want it to be about credits. Equation 2, I want it to be about courses. So since equation 1 is about credits, we have a total of 59. Equation 2 is about courses. We're taking a total of 18. Now, this person could have been a junior in college or something, so they've already taken 18 different classes. Yeah, it wouldn't be a freshman. You usually take 5 or 6 classes per semester. Okay, so I know that every time I write an X in credits, I need to put a 3 next to it because every X is worth 3 credits. And I'm talking about credits. So 3X. Every time I put a Y for credits, I need to put a 4 next to it, plus 4Y. Here is my equation for credits. 3 credits times the number of X's, 4 credits times the number of Y's equals 59 total credits. Now for courses, I am just going to put an X because I don't know how many classes I'm taking that are worth 3 credits. X plus Y, I don't know how many classes I'm taking that were worth 4 credits. We don't put a 3 and we don't put a 4 on this equation because it's not describing credits. It's describing courses. And remember, I have the word courses in each of my definitions. If I don't attach the 3 and the 4 to it, I'm good. Now we need to transform both of these into y equals mx plus b. Box the y, move the x, divide, divide, divide. Box the y, move the x, divide, divide, divide. 4y equals 59 minus 3x, divide everything by 4. I can tell you right now, I bet 59 is not divisible by 4. So I am just going to rewrite it as 59 divided by 4. Remember, we don't want to round when we're graphing these systems because then your intersection point won't be one of the 4 choices. Don't want to round. Leave it as a fraction. On equation 2, it's super fast. Box the y, move the x, and we're done. Because y is already positive. So that's 18 minus x. 18 minus x. All right, let's type both of those into Desmos. So do it with me. Y equals 59 divided by 4 with a minus 3 divided by 4 with an x. Y equals 18 minus x. I can't see them. I come over here, I tap it. 13 comma 5 is the solution. But what was the question asking? How many courses are worth 3 credits? I only care about the one worth 3. As you see back up here, x represented the one with 3. So I only need to circle the answer for the x coordinate, which is the first number, which is A. Okay, number 37. Notice the bottom equation is ready for graphing. The top equation is not. What is the value of x in the solution? So again, this is our third star question that only cares about what is x. Ironic, weird. We need to find where it's the solution and only pull out the x coordinate, remembering that x is the first number in each point. We can type this into Desmos. Y equals negative 5x plus 32. Got it. Now, for this equation, let's go ahead and box the y. Move the x. That gives me negative 5y equals 22 minus 3x. And then we're going to divide, divide, divide. Again, for all of you that mess stuff up when you're reducing, just type it in like you see it. 22 divided by negative 5. Okay, y equals 22 divided by negative 5. Notice it's not an even number because y equals negative 4.4. So leave it as a fraction. Then type in minus 3 divided by negative 5x. So you can type a double negative. Or if you remember that a negative divided by a negative is a positive, you can type it as a positive. But notice the red line does go up, which means it's a positive slope. So I could delete the minus here and then delete the minus there and put a plus, and it still looks the same. Here's my final equation. Again, I need to only care about the x coordinate, which is 6.5 comma negative 0.5. So that's going to be choice C. Question 4 is star question number 18 from one of the years. A bus travels 2 different routes. We've got the green route, we've got the blue route. The routes are different lengths. On Monday, the bus traveled the green route 6 times, the blue route 5 times, traveling a total of 52 miles. But on Tuesday, the bus traveled the green route 12 times and the blue route 13 times, traveling 119 miles. What is the length of the green route? It only cares about the green route. So what 2 things are we talking about? A bus going where? Green and blue route. So that tells you that one of these routes has to be your x and the other route has to be your y. I now have defined my variables. First thing you do is define variables. Now we're ready to write an equation. So let's do it. Let's write an equation for Monday. Here we go. The green route 6 times, so 6x. The blue route 5 times, so plus 5y, for a total of equals 52 miles. Now let's write an equation for Tuesday. We have green route 12 times, 12x. Blue route 13 times, 13y, traveling 119 miles. Okay, what is the length of the green route? So that means we need to find the solution and only care about the green route, which is x. So we're going to find the solution, and then we're going to circle and point out the x. Now, with that being said, I need to transform both of these so I can graph them in Desmos. Here we go. We're a robot. Pox the y. Move the x. Divide, divide, divide. Again, I'm not going to reduce anything because none of that looks friendly to reduce. So I'm going to type in y equals. Y'all do the same right now. Y equals 52 divided by 5 minus 6 divided by 5 with an x, and there it is. Now let's do the other equation. Box the y, move the x, divide, divide, divide. Divide by 13, divide by 13. None of that looks friendly. So I'm just going to type it in like I see it. Y equals 119 divided by 13. And notice it says 9.15, blah, blah, blah. We'll leave it as a fraction. Minus 12 divided by 13 with an x. They do intersect nicely. There's the gray dot. They intersect at 4.5, 5. I only care about the x, so my answer is choice G. So it looks like I tried to give you a tip for number 5, which says write both equations below, transform into slope-intercept form, then graph into Desmos. So we got to write the equation, we got to transform it, then graph it. This is a very meaty, challenging problem. Okay, because it has so many steps. Okay, here we go. 2 customers went to a post office to buy a postcard and large envelopes. Each postcard cost the same amount. Okay, that's important. Each postcard I'm buying costs the same amount. Each large envelope costs the same amount. Cool. The first customer paid $12 for 14 postcards and 5 large envelopes. The second customer paid $24.80 for 10 postcards and 15 large envelopes. So what's my question going to say? First thing we do is define our variables. We've got x equals postcards, y will equal large envelopes. Okay, if you want to take it shortcut, just call this x, postcards, y, large envelopes. Okay, so let's write our 2 equations. We need an equation for the first customer, an equation for the second customer, and then the question says, what's the cost in dollars of the large envelopes? Finally, they care about the little y coordinate. Thank you, star test. Okay, here we go. Here is our first customer. We're going to write that right here. $12. So 12 equals 14 postcards, 14x, plus 5 large envelopes, 5y. Okay, box the y, move the x, divide, divide, divide. I'm doing it like this on purpose because it's not comfortable. None of us are comfortable right now because it's all backwards. And you're like, oh, I don't like this. You have to be okay with doing something new or rewrite it the way you feel comfortable. That's not hard. Again, none of this is friendly for reducing. So just leave it as 12 over 5 and leave it as 14 over 5x. There's our answer for the first equation. Now let's get our second equation for the second customer right here. That one's going to be, I'll write this one the other way. 10 postcards, 10x, 15 large envelopes, 15y equals $24.80. Again, I feel very robotic. Box the y, do the opposite, move the x, divide by 15, divide by 15, divide by 15. Rewrite the equation. I know that $24.80, I'm just going to leave it as divided by 15. I do know that 10 over 15 does reduce. I'm not going to reduce it. Just going to leave it like that. Desmos will graph no matter what, and it'll graph it correctly. Here we go. Cross out, cross out. So one of our equations was y equals 24.80 divided by 15 minus 10 divided by 15 with an x. The other equation was y equals 12 divided by 5 minus 14 divided by 5 with an x. In this example, they care about the y-intercept. And remember, y'all, this is money. Money can look freaky like this. This would be 35 cents for the cost of whatever x represented, and $1.42 for the cost of the other. I think that was large envelope and postcard. It makes sense. A postcard's 35 cents. Notice they give you the answer for 35 cents and $1.42. You've got to know which one they care about. They care about the y value. The y value is $1.42. Our answer is A. The last example, again, here's a solution. I only care about the x. All right. This one doesn't follow the rules. This one says x equals, and I can guarantee you, I don't know if Desmos will graph that. Let's check it out. 2y minus 4. It does! Then don't worry about it getting in the y equals form. And this is the star version. Wow. Okay, cool. This one's done. Now let's graph this one. Box the y, move the x, divide, divide, divide. Again, I know that 66 negative cannot be divisible by 5. Leave it. I also know that 7 is not divisible by 5. Leave it. Type it in. Negative 66 divided by 5. Make sure you're typing in all the minus signs. Zoom out. Can't see it. Oh, they're intersecting at a negative place finally. Ooh, so the answer to the system is -8, -2. They only care about the x, and the answer is H. Okay, ask me if you need any help right now. Moving into the next phase of our day is going to be opening your review for the final and start working on questions 1 through 11. I'm going to record a video on how to do those 11 that we will watch our next class, and then we'll be assigned problems 12 through 22, and we'll go over that on Monday, which is our C day. All right, peace out.